Today I'm going to talk about, continue talking actually about CompletableFuture in Java 8. In last lesson I talked about, I'm not going to call it lesson, let's say like sharing some knowledge that I learned while reading the Java 8 in Action book. So in this, let's say session, I'm going to walk you through the performance of the parallel stream and the CompletableFuture. Actually, there is something that we need to be aware of. Like sometimes even using the CompletableFuture can lead to sequential process, and to avoid that, I'm gonna show you what is the process to avoid that, and I'll show you like some calculation to prove that CompletableFuture sometimes can be the bottleneck. So how that could happen, let's go back to the example that we have here. So here I have actually three cases. The first one of them, I'm gonna show you how to consume sync using the CompletableFuture itself. So if you look at this example that we have here, where we are using the CompletableFuture here, and if you are not aware of how to do the CompletableFuture, I'm going to walk you through this function. If you're not familiar with default keyword, I talked about this default keyword in Java 8 in another session. You can go back to it and maybe listen about it. So mainly here in this example, we are creating a CompletableFuture of a string because we are expecting the result back to be a string, and then we call this function which is getText here, and this function is having a delay for 1 second, and after that we are returning just the string. If you see here, we are executing the complete function, and this method will block the caller until it finishes and until it complete, like do the calculation and then comes back. So if we go back to our example here, we're gonna see that we are using the for each, and we are calling each API that we have, and we have actually 3 APIs here, like 3 APIs in the list. So what happened here? Like we're gonna call this CompletableFuture text, and it's gonna be blocked until the result comes back, and then it's gonna proceed to the next one, the third one, and etc. etc. So to avoid that sequential process, there is a way to do that. By first we're gonna gather all these future streams in a list, and then later we're gonna execute them using the for each. What does that mean here? In this case, we're gonna gather all of them in a list, so when we execute them, then they will not wait for each other to complete. And I have here like from the book, there is like kind of slide that let me make it bigger maybe. So if this in this slide, if you can see here in this case, the first one like will not start until the second one, sorry, will not start until the former is completed. So in this case, using the CompletableFuture will not give us the benefit that we were expecting to, because it has to do the get the result, and we will be blocked until it comes back, then the second one will start. But if when we use the list here, all of them in this oval area, all of them will be created. So the minute we call them, they are not gonna, like when we call them to get the result back, they will not wait until the next one, until the former one is completed. And in this case, we're gonna guarantee that they run in parallel. I'm gonna show you now the example that I have here, and this is the test that I have actually. The test actually is comparing, as you can see, these are the three APIs that we have here. The test includes three cases. One of them is the sequential, one of them is the CompletableFuture using the list, gathering them in a list, and the third one is using the parallel stream. So let's run the three examples, and I'm gonna show you what's gonna happen. First, let me do this, and I'm gonna run the first one. So as you can see, they run in sequential, and it took around like 3000 milliseconds. Let's now run the second one, which is the CompletableFuture, but first we gather them in a list. Let's run this example and see what's happened. Yes. So you see the sequential running first, then the CompletableFuture using the gathering list. As you can see, it took only 1000 milliseconds. And imagine if you have like 1000 APIs, they can run in parallel. But wait, there is another thing that I need to talk about in here. So here, as you can see, it took 3000 milliseconds, and this one took 1000 milliseconds. The last case here is the parallel stream. We're gonna run all of them now, and let's run all of them. So the sequential first, as you can see, 3000 milliseconds, and here is the CompletableFuture in a list, and the third one is the parallel stream, and it took less time than the others. And if we look at the parallel example here, you see the code is very clean, it's very short. You don't have to write much. It's just just use the parallel stream instead of using the stream in this case, and using the map and gather all of them, using the join and then call all of them. So some people say, okay, so why do I need to use the CompletableFuture in this way if I can write the parallel? If I can write a parallel stream and without even using the CompletableFuture, and it will give me a better result. Actually, there's something that we can control using the CompletableFuture, and I'm gonna talk about this subject later, which is using the executor. We can apply a custom executor to control how many threads are in the pool. Or we can pull, we can, using a formula, math formula, we can decide how many threads we can have in the pool ready, and we can pull how many threads we want and return them back. So which one is better? Is like parallel stream or using the CompletableFuture? Actually, this is what I'm going to talk about this in details next time, and I think it's very interesting subject to talk about. And just to have a hint about it, it's like parallel stream can sometimes defeat the CompletableFuture based on the hardware that we have, based on the number of processors that we have. But since we cannot guarantee how many processors we have, how many threads we have, we can guarantee that using the the executor, the custom executor that we can use in the CompletableFuture. In that case, we can have more control, and CompletableFuture can win in that case. So this is what I have for today. I hope you find it like uh, I have like it has some benefit for you, and looking forward to the next session. See you later.